notes for the last section in Unit 1. It's Section 1.5, Angle Relationships. We're going a little bit out of order because we think this makes a little bit more sense in terms of you learning. You might remember our last section was Section 1.7. The objectives are I will be able to identify and use special pairs of angles, and number 2, I will be able to identify perpendicular lines. So this section mostly just has a lot of different vocabulary words for you to learn. The first vocabulary words are adjacent angles. They are two angles that lie in the same plane, have a common vertex and a common side, but no common interior points. So inside this definition, we have a number of other words which we've defined earlier. So we have vertex. So remember, vertex was like an elbow point, is what I like to call it. So it's like the center of the angle. So if I look at angle SRT, which I just highlighted in red, R is the vertex. That's the turning point, the elbow point. So if I take angle SRT, and I want to find out what it is adjacent to, that means it has a common side, but no common interior points. That means no points are the same on the inside. Well, the only adjacent angle that's shown here is angle PRU. So those are adjacent angles. Do you see how they share a side, ray TR, and they have no interior points? To demonstrate the interior points a little bit better, I'm going to give two angles that are not adjacent with this next picture. So angle AEC and angle AED are not adjacent. The reason they're not adjacent is because all of these points in between here are shared. Those are common interior points. Instead, angle AEC and angle CEB are adjacent. So I'll highlight the other angle in black. So angle CEB. So ray CE is the shared side. So hopefully you get adjacent angles. You should just think next to. Vertical angles are incredibly important. Vertical angles and linear pairs are probably the two most important things that you will have to remember this year. There's a couple ways that I like to remember vertical angles. First off, I say opposite corners. And we also have hourglass and butterfly. I'll explain those, hourglass and butterfly, in a second. But they are two non-adjacent. So remember, we just learned adjacent is next to. Angles formed by two intersecting lines. So if I take a look at angle 4 and angle 2, they're opposite corners. Those are adjacent angles. Now, why did I say they were butterfly angles? Because you should remember from our earlier notes, those angle marks mean they're congruent, and vertical angles are congruent. So whenever you see those two angle marks that are on opposite corners, those are adjacent angles. The other pair of adjacent angles here are angle 1 and angle 3. And again, whenever we do the angle marks, this time I'll put 2 because we did 1 last time. They sort of look like an hourglass with sand going down. That's where we get those three little ways to remember vertical angles. Linear pairs are a pair of adjacent angles whose non-common side are opposite rays. So the easier way for me to tell you how to remember linear pairs, it has the word line in it first off. And it's basically cutting a line in two. So if I take a look here, line AB is the line, and I cut it in two with ray BD. So I would say angle ABD and angle DBC are linear pair. There's a number of linear pairs here, but again, I take one line and I cut it. So that would mean angle PXQ and angle QXT are the linear pair. Another way I could do this, I take this same line again, I cut it here. That would be angle PXR and angle RXT. We could also come up with another pair of angles that form a linear pair with ray XS. But we're going to move on to complementary angles. So complementary angles are two angles whose measures have a sum of 90 degrees. So quite simply, 60 plus 30 equals 90. That's complementary. This symbol right here, the box means 90 degrees. In a second, I'll show you a good way to remember complementary angles. First, we need to talk about supplementary angles, though. Supplementary angles are two angles whose measures have a sum of 180 degrees. So right here we have 120 plus 60 is 180. So to the left, those are supplementary angles. And the other thing you need to remember are linear pairs are supplementary. So if you don't remember what linear pairs are, we just defined them a second ago. So the easy way to remember the difference between complementary and supplementary. So we have a C and we have an S. Complementary angles are 90 degrees. Supplementary angles are 180 degrees. So whenever you draw that C and the S, it's going to help you remember what the difference is. We just have a few more things. We have perpendicular lines. They are two lines, rays, or segments that intersect to form right angles. So remember, right angles are 90 degrees. So the symbol is this upside down T. It's read perpendicular to. We don't know that line AC and line DB are perpendicular unless we have a box. Remember, the box means 90 degrees. So again, means 90 degrees and perpendicular lines. So remember, that symbol means perpendicular. The last thing here is the angle addition postulate. We have if point B in the interior, this should be angle AOC. If point B is in the interior of angle AOC, then the angle AOB plus angle BOC is equal to angle AOC. We've already talked about the angle addition postulate. So remember, it's just this part plus this part, so the two small parts equal the whole angle. That's it. So to figure this out, the last thing we're going to do is this one example here. It says SXT, the measure of angle SXT, which is right here, is 3a minus 4. And we're told the measure of angle RXS is 2a plus 5. And lastly, we're given this angle RXT. The whole thing is 111 degrees. So again, one part of the big angle plus the other part of the big angle is equal to the whole angle. So we need to do some simple algebra to figure this out. So one other thing that you might be familiar with from Algebra 1 is this DCIAM. These are the order of operations you need to follow. The first one you need to do is combine like terms. So when we combine like terms, we have 2a plus 3a is 5a, and we have plus 5 and minus 4, so plus 1 is equal to 111. We already isolated the variable. Because a is the variable, it's already alone. Now we need to add or subtract. So we're going to subtract 1. We get 5a is equal to 110. And the last thing is multiply or divide. So we need to divide by 5. And we will get a is equal to 22, which was one thing we were looking for. The other thing we were looking for was RXS. So that was 2a plus 5, 2 times 22. All I'm doing is substituting, and I get 49. Try this one on your own. We should have a lot of practice with the angle addition postulate. I hope this was helpful, and again, please ask me any questions you might have.